Hi guys, welcome to this video on the 2019 Level 3 integration paper. So for this video, I might just do question 1 and question 2, and I'll leave question 3 for another time since it's getting a little bit late today. So question 1a, find the integral of 2 plus of 2 over square root of x dx. So for this question, the easiest course of action is to move the square root of x to the numerator, and to do that we need to inverse the power. So that becomes integral of 2 plus 2 over x to the power of 1/2, which means that it becomes 2 plus 2 times x to the power of negative 1/2 dx. And now all we need to do is use the power rule. So we add 1 to the power and then we divide by the new power. So this will be equal to 2 becomes 2x plus of 2x to the power of 1/2 divided by the new power, which is 1/2. And do not forget our constant of integration. So now we have 2x plus of 2 divided by 1/2 is 4. So 4x to the power of 1/2 plus c. And if you want to make it look a little bit neater, you can write 2x plus 4 root x plus c. And that is an achieve level question. Question B. Use the values given in the table below to find an approximation to the definite integral of between 5 and 2 of f of x dx using the trapezium rule. Okay, so for the trapezium rule, it states that, so if we look on our formula sheet, it states that the definite integral between 5 and 2 is equal to 1/2 of the height times of y0 plus yn plus 2 y1 plus keeps going on. Okay. So what this means is the height here is corresponding to the intervals between each of these tables, which is 0.5. That's corresponding to this height here. And y0 is the first column, and the yn is our nth column, which is our last column. The reason that these only get counted once is because they're on the outermost edge, which means they bound only one other trapezium. For all of these middle values, each of these middle trapeziums are bounded another trapezium, one on each side, which means they'll effectively get counted twice, which is why we have a 2 times of everything in between. So if we look at this, it becomes 5, 2, becomes 1/2 times of 0.5 times of y0, which is 0.6, plus yn, which is 2.6, and then plus 2 times of everything inside, which is 1.1 plus 1.7 plus 2.6 plus 3.2 plus 3.4. Alright, so if you do some quick work on your calculator, you should get that this is equal to 6.8. And let me check the marking schedule. Yep, that this is the 6.8 is our answer. And that is again another achieve level question. Question C. Find the integral between pi over 2 and 0, the definite integral, cos 4x times cos 2x dx. Okay, so right now in this form we cannot integrate. Okay, so I mean we could integrate by, we could use substitution method, but personally that's not needed in this case, because we can use, we can convert cos 4x times cos 2x into a different form by using our product rule. So we can say that, so we can use our product rule, so we can say 2 cos A cos B is equal to cos of A plus B plus cos of A minus B. So in this case, cos 4x cos 2x, that becomes 1/2 of cos of A plus B, so 4x plus 2x, which is 6x, plus 1/2 of cos of A minus B, which is 4x minus 2x, which is cos 2x. So now the problem becomes like this. Alright, so now we can integrate. So to integrate, our cos goes back to sine, and we need to divide by the derivative of whatever inside in the function. Because when we differentiate, we multiply by the differentiate in the function. So when we go back, when we integrate, we need to divide instead. So we will have that 1 over 12 sine 6x plus 1 over 4 sine 2x. And we don't need the constant of integration because it's an indefinite integral, so we're trying to find the differences. So if we're trying to find the differences, the two c's will cancel out, so there's no need to write it in our calculations. So between pi over 12, so it becomes 1 over 12 sine of 6x. 6 times of pi over 12, that's pi over 2. Plus 1/2 of sine 2x, which is pi over 6. Minus everything, if we put 0 for everything. So sine of 0 plus 1 over 4 sine of 0. So you know sine of 0 is just 0. So this whole integral, this whole section is just 0. So sine of 1/2. So if we can calculate the sine of 1/2. Sorry, I'm on degrees. Sorry. Right, so remember your calculator should be set to radians, not degrees. Very important. So we have 1 over 12 plus 1 over 4 sine of pi over 6. So we have 1 over 12 plus 0.4 times 0.5. So 1 over 12 plus 1 over 4 times. Sorry, 0.25 times 0.4. Alright, that should give us an answer of 5 over 24. 5 over 24 is what I'm getting. Yep. So our answer is 5 over 24, and that is a merit level question. To get an achieved, you should have a correct integration. So correct integration here will get you an achieved. Right, so the graph below shows the curve y equals 6 over root 3x plus 1. Show that the areas of region A and B are equal. Alright, so the way I like to do these questions is I prefer to use the substitution rule for 3x plus 1. So we can say if we're trying to find the integral, Alright, trying to find the integral of 6 divided by square root of 3x plus 1 dx. So in this case, I would say I'll let u be equal to square root of 3x plus 1. So therefore, So therefore, du over dx will be equal to 1/2 times of 3x plus 1. You bring the power down, so convert this as 3x plus 1 to the power of 1/2. So we bring the power down, and then we bring the power down by 1. So it becomes negative 1/2 times by the differentiation of the inner function, which is 3. So du over dx is equal to 3 over 2 root 3x plus 1. And so now we need to rearrange for dx. So 3 dx equals to 3 root 3x plus 1 du. So I'm just cross multiply. So therefore dx equals to 2 root 3x plus 1 over 3. Alright, so now we can substitute dx back for du. So we now can have over u multiplied by 2u over 3. So u and u cancel out, and then we'll have 12 over 3 du. And if we integrate this, we'll get 4u plus c, but because we're trying to find indefinite integrals in this case, we don't really need to have this plus c. So we have 4u, which is 4 times of square root of 3x plus 1 is our integral. Okay. So we're trying to prove that the area of A is equal to the area of B. So the area of A can be found with the indefinite integral of 0 of our function 6 over square root of 3x plus 1, and the area of B will be the same but 16 between x equals to 16 and x equals to 5 of the same function. Alright, so we have our 4 root 3x plus 1 between 5 and 0. Right, so we substitute 5 and we'll get 4 square root of 16 minus 4 times of square root of 1. Okay. So that will become 16 minus 4, that equals to 12. Okay, so this area of A, so area of A equals to 12 units squared. Right, so for B, it's between 16 and 5, so we can find the indefinite integral between x equals to 16 and x equals to 5. So that equals to 4 root of 16 times 3 is 48, plus 1 is 49, minus 4 root of substitute 5, which is 4 root 16. So square root of 49, that is 7. 7 times 4 is 28. 28 minus 6, square root of 16 is 4. 4 times 4 is 16. So 28 minus 16, that is also 12. So you can say that left-hand side equals to right-hand side. So 12 equals to 12, which means that the area of A and B are equal. So we have done as required. And this is an merit level question. So if you can prove that both of these areas are equal, you'll get a merit grade. To get an achieved grade, if you can have a correct integration, which is up to here. So 4 times root 3x plus 1, correct integration achieved. Right. The rate of change of quantity n at any rate is given by the differential equation dn over dt equals to kn. If n has positive values n1 and n2 at times t1 and 2t1 respectively, prove that k equals to 1 over t1 ln of n2 over n1. Alright, so for this question we want to move the variables one to one side and then differentiate each side accordingly. Okay, so dn over dt equals to kn. So if we do this one step at a time, we have dn equals to kn dt. So therefore 1 over n dn equals to k dt. So now we can integrate both sides. We can say integral of 1 over n with respect to dn equals to k integral of k with respect to dt. So integral of 1 over n, that is ln of n, and that is equal to kt plus c. So if we make n the subject of the formula, what we're trying to find? Trying to find k is the subject of the formula. Okay, so instead we will have ln of n minus c divided by t. That equals to k. Alright, so if n has positive values n1 and n2 at times t1 and 2t1 respectively, okay. So when t equals to t1, our sorry, what am I saying? If n has positive values n1 and n2 at times t1 and t2, actually, I think it would be better to make n the subject of the formula for this one, actually. So if we say n is equal to ae to the power of kt, so we move the c and we put it as a multiplier of e. So n equals to ae to the power of kt, and therefore we can say n1 is equal to, when t is t1, so we can say n1 equals to ae to the power of kt1. And we also know that n2 is equal to ae to the power of k2 t2. Right, so alright, so if we do this is equation 1 and equation 2. If we did equation 2 divided by equation 1, so n2, so just equation 2 divided by equation 1, so it becomes n2 over n1 is equal to a divided by a, that is cancels out completely, and now we have e to the power of kt2 over e to the power of kt2 e to the power of kt1. And now we're trying to make k the subject of the formula. So if we divide, so n2 over n1 is equal to, we can what can we do here? We can shift this bottom numerator to the denominator up to the numerator. So we can say kt2 multiplied by e to the power of negative kt1. Therefore n2 over n1 is equal to, so in this case we're going to be adding the powers, because when you multiply 2 you add the powers, so e to the power of kt2 minus kt1. So therefore ln of n2 over n1 is equal to kt2 minus kt1. So if we take k as a common factor, so ln of n2 over n1 is equal to k take the k out. Okay, so t1, t2 minus t1. All right. Oh, why do I have t2 here? What is t2? Oh no, that's 2t1. Sorry. Oh, what am I doing this whole time? It's been 2t2. Apologies, guys. It's actually not t2. It's 2t2. Apologize to 2t2, 2t2, so 2t1. Sorry, 2t. Alright, so what we would have had here is if we had 2kt1, so what we have here is actually 2kt1 minus kt1. So that actually gives us kt1, and if we divide both sides by t1, so we'll get 1 over t1, ln of n2 over n1 is equal to k, which is what the question wanted us to show. So getting all the way up to here should get you an excellence grade. To get a merit grade, if we have a correct equation involving n1 and n2. So if we have, let's say, if we had, not that step, sorry. If we had this up to this step here, that will get you a merit grade. To get an achieved grade, if you can separate the variables correctly, so separating the variables will get you an achieved. Yeah, so once again, I'm sorry about writing the T2 that. I don't know what I was thinking. It obviously said 2T1 in the question, and I accidentally wrote T2. So my bad there. Alright, so moving on to the next question. Find the integral of 1 plus 2 e to the power 4x dx. Alright, so oh, sorry, my pen. Come on. Integral of 1 plus 2 e to the power 4x dx. Alright, so when you differentiate an exponential, you actually multiply by the derivative of the power. So when you integrate, you're going to divide by the derivative of the power instead. So you're going to do it the opposite way around. So 1, if you integrate 1, that just becomes x, and plus 2 divided by the derivative of the power. Derivative of 4x is 4, so plus 2 over 4, and the power of e stays the same, plus c. So equals x plus 1 over 2 e to the power 4x plus c. And that is just an achieved question there. Okay, so the graph y equals to f of x shown below has the y-axis as a line of symmetry. The areas of the shaded regions are shown. If the definite integral of x equals to a, between x equals to a and x equals to negative a, f of x dx equals to 5.8, what is the value of the definite integral of b, of between x equals to b and x equals to negative b, f of x dx? Okay. So the, oh, no red pen again, sorry guys. Alright, so this definite integral actually calculates the sum of this area and these two areas. However, any area below the x-axis is counted as negative, okay? So therefore, what this is saying is that we'll call this area area A. So basically what this integral is saying is that negative 2.4 plus of A is equal to the value 5.8. So if we rearrange this, we know that our A is equal to 5.8 plus 2.4, which is 8.2. The indefinite integral of b and negative b is actually asking us for this middle area here between b and negative b. So that is actually indeed equal to our area. So we can say that the integral of f of x dx equals to 8.2. And that is an achieved level question. Alright, question C. Find k such as the indefinite integral between x equals to k and x equals to 3, 8 over 2x minus 5 dx equals to 10. Okay, so first things first, we need to integrate. Alright, to integrate this function, we're obviously going to have an ln function here. So we're going to find, the integrals of k3, 8 over 2x minus 5 dx equals to 10. Alright, so notice that we have 8 in the numerator, and the derivative of the denominator is 2. So when we have an ln of function, we have for example we have ln of 2x minus 5. So when we differentiate this, we'll actually have the derivative of the inner function multiplied by the derivative of the ln function. So the derivative of the ln function is 2x minus 5, and you have to multiply by the derivative of the inner function, which in this case is 2. So if you're looking back here, so we have 8 in the denominator, and we need to multiply by 2 with the ln. So instead of having 8, we'll have a 4 outside the ln. So when time comes, we can multiply by 4 to get the 8 we need at the top. So what we actually have here is 4 ln of 2x minus 5 between k and 3 equals to 10. So 4 ln of 2k minus 5 minus 4, sorry, put this in brackets, times 4 ln of 3, so ln of 1 equals to 10. So ln of 1 is just 0, ln of 1 is 0. So therefore 4 ln of 2k minus 5 equals to 10. Divide both sides by 4, so ln of 2k minus 5 equals to 2.5. And if you if we quote unquote move the ln to the other side, so we have 2k minus 5 equals to e to the power of 2.5, because ln is base e, remember, so ln is base e. So basically if we can write it like this, so equals 2.5. So if we know our log rule, so e to the power of 2.5 equals to 2k minus 5. So that's how we got that answer there. And therefore we'll have that our so e to the power of 2.5 plus 5 divided by 2 equals to k. So e to the power of 2.5 plus 5 divided by 2, we should get that our k value equals 8.591. And to get this answer, you should get a merit grade. To get an achieved grade, if you have a correct integration, you will get a merit grade. So the correct integration up to the step here is an achieved. The diagram below shows the graph of the function y equals to cos squared x. Find the area of the shaded region. So as it stands right now, we cannot actually integrate straight away. We need to substitute this into something that we can integrate. So we know that from our double angles rules, we know that 2 cos, not red pen again, I'm so sorry. Okay. So we know that 2 cos squared of x minus 1 equals to cos of 2x. If we rearrange this equation for cos squared x, we'll get that cos squared x equals to cos 2x plus 1 over 2, which is equal to 1/2 cos 2x plus 1/2. So now we can reword the question. So we can now say that we're trying to find the area between pi and 0 of the integral of cos 2x plus 1/2 dx. And now it becomes very simple. For a cos rule, cos goes back to sine, and we need to divide by the derivative of the inner function. Derivative of the inner function is just 2. So 1/2 divided by 2 is 1/4. So 1/4 sine 2x plus of 1/2 of x between pi and 0. Okay, so 1/4 of sine 2 pi plus 1/4 of pi minus 1/4 of sine 0 plus 0. And that should be that should just give us an answer of 1/2 of pi, and that's because sine 2 pi is 0 and sine 0 is 0. So we should get the answer is 1/2 of pi for this question. Let me just double check. Yep, 1/2 of pi or pi over 2. And that will get you a merit grade. To get an achieved grade, you're looking at the correct integration. The correct integration is up to this step, you'll get an achieved. The diagram below shows the graphs of the functions y equals to e to the power of x, the whole thing to the power of 2, and y equals to 20 minus e to the power of x, whole thing to the power of 2. Find the area shaded in the diagram. So the way I like to remember this is that the area between the curve is actually the area of the upper bound curve minus the lower bound curve. So we're trying to the curve that's on top is y equals to 20 minus e to the power of x, whole thing to the power of 2. So therefore, 20 minus e to the power of e to the power of x, so e to the power of x squared, that equals to e to the power of x times e to the power of x, which equals to e to the power of 2x, because when you multiply two items of the same base, you add the power, so it becomes e to the power of 2x minus the equation of the lower curve, so minus e to the power of 2x. So we can say this is our, we'll just call it y, and this equals to 20 minus 2e to the power of 2x. So now we need to find the integral. So the integral is trying to find the indefinite integral, or we need to find this point of intersection. So to find the point of intersection, we need to make the two graphs equal to each other. So 20 minus e to the power of 2x equals to e to the power of 2x. Alright, so 20 equals to 2e to the power of 2x, therefore 10 equals to e to the power of 2x, because you divide both sides by 2, and then you take the natural log of both sides, and that equals to 2x, so therefore x equals to ln of 10 over 2. So we'll just leave x equals to ln 10 over 2, we'll just leave it in that form to be more accurate. So ln of 10 over 2 and 0. And that's the integral of 20 minus 2e to the power of 2x dx. Alright, so that will become 20x minus, okay, so the derivative of 2x is 2. Negative 2 divided by 2 is just negative 1. We don't need to write the negative 1. We just need to write negative e to the power of 2x. And that's between half of ln of 10. Half of ln 10 and 0. So 20 times of 1/2 ln of 10 minus e to the power of 2 times of 1/2 ln of 10 and minus 20 times of 0, so that's just 0, minus e to the power of 0. Okay. So 1/2 of ln 10 by 2 times 20. 2 times 2 is just ln of 10. Alright, so we have that will come out to be 10 and 1/2. So 23.03 minus 10 minus of negative 1, because e to the power of 0 is 1, so minus 1, so it becomes plus 1, so therefore 23.03 minus 10 plus 1, that equals to 14.03. And that should be our answer. Yeah, 14.03, and that will give us an excellence level grade. So, excellence level grade. To get a merit grade, you have a correct integration. So correct integration here will get you a merit. To get an achieved, you can just write it in the form of into this form. It looks like you can get an achieved grade. Alright, so I'm going to stop there for now. It's getting a little bit late, so thank you for watching this video, and I hope to see you all in the next one. Thank you.